Imagine being done with GED science and being able to move ahead to bigger and better things in life, like college, or a better job, or joining the military, whatever your goal happens to be. Well, I'm going to help you do that in this video, and we're going to get started right now. In a chemical reaction, the substance or substances initially involved in the reaction are called the reactants. The reactants are rearranged in the chemical reaction to produce one or more different substances known as products. All chemical reactions involve energy. A reaction in which energy is given off is called an exothermic reaction, whereas a reaction in which energy is absorbed is called an endothermic reaction. In order for a chemical reaction to proceed, a certain amount of energy, called activation energy, is needed. Now, your question is right here. It says, what kind of reaction is the graph above an example of? Now, the graph is not actually above. The graph is right here to the left. But anyway, I want you to tell me, is this an exothermic or an endothermic reaction? So if you'd like to, now's your chance to pause the video, take all the time you need with this, and whenever you're ready, we'll go over the answer. Okay, so basically here in this case, this is an exothermic reaction. So in an exothermic reaction, energy is given off. And in this case here, we see that on our vertical axis, we have potential energy. So here is the energy level of the reactants. Now down here is the energy level of the products. So we basically see that, as the reaction proceeds, at the end of it, the products are going to have significantly less energy than the reactants. Energy was given off, so we call this an exothermic reaction. So here are some notes that will be helpful to you for endothermic and exothermic reaction questions. For exothermic reactions, you should know that energy is given off and temperature increases. And for endothermic reactions, you should know that energy is absorbed and that temperature decreases. Daphnia, also known as water fleas, are a small crustacean commonly found in bodies of water such as lakes and ponds. Being that Daphnia are transparent, researchers can visualize Daphnia's organs using a microscope. Researchers are interested in measuring the effects of dopamine and ethanol on the heart rate of Daphnia at various concentrations. Okay, so here we see a chart, and this should say average heart rate in beats per minute, but down here it says concentration of dopamine. And so over here we have our answer choices. And the question says, which of the following statements is best supported by the chart? A. As concentration of dopamine increased, heart rate decreased. B. As concentration of dopamine increased, heart rate increased. C. As concentration of dopamine increased, no change in heart rate occurred. Or D. None of the above. So now is your chance to pause the video, try to figure this out, and take all the time you need. And if you get stuck, don't worry. All we care about is the learning right now. We don't care if you get it right or wrong. So let's have you pause the video if you'd like to and give this a shot. Okay, so hopefully you had a chance to try this question out. So basically, this is a graph rating question. And what I want you to see here is that over here on our vertical axis, all right, it's average heart rate in beats per minute, and the numbers are increasing from bottom to top. Okay, now over here on our horizontal axis, we see concentration, and we see the numbers are getting bigger going from left to right. Okay, and what we also see here is that we have what I like to call the staircase effect. And basically, if you were to imagine there was a stick figure person, all right, that started right here at the leftmost part of the graph. Okay, if this person were to walk from this bar to this bar to this bar to this bar, there's a little increase to this bar. Okay, with each step that person took, they'd be kind of going up a staircase right here. All right, so in other words, we see from left to right, we see a big increase. So as concentration of dopamine increased, heart rate also increased. Now, of course, if you can just look at the graph and you can tell that the right answer here is B. As concentration of dopamine increased, heart rate increased. That's, you don't have to think about it like a little stick person, obviously. I just think for some, especially beginners, it can be easier to kind of visualize this like a staircase. Okay, so this time the scenario is exactly the same, but we're now looking at the results of the ethanol. And here's our chart with the ethanol this time. It says average heart rate in beats per minute, this should say. And down here on our horizontal axis, it says percent ethanol. And the answer choices this time, or the question says, which of the following statements is best supported by the chart above? A, as percent ethanol increased, heart rate decreased. B, as percent ethanol increased, heart rate increased. And then we have C, as percent ethanol increased, no change in heart rate occurred. Or D, none of the above. So now's your chance to pause the video, try to figure this question out, take all the time you need, and as always, if you get stuck, don't worry about it because we're just going to go over the answer. Okay, hopefully you had a chance to try this. So in this case, we also see kind of that staircase effect, but this time, all right, if we had a person that were to start up here at the leftmost part, if the person were to step from one bar to the other, going from left to right, this time, all right, that person would be going down the steps with each step. Okay, and so the height of each bar, all right, that reflects the average heart rate in beats per minute. So if the person is going down each time, all right, that tells us that the heart rate decreased with each step to the right. All right, so we note here that down here, the percent of ethanol, right, the concentration of ethanol is increasing as the person walks from left to right, but the heart rate is decreasing with each step from left to right. Okay, so in this case here, as percent ethanol increased, we see that the heart rate is decreasing. So A is the correct answer here. If you got that right, great work. If not, hopefully you see why A is the correct answer now. The Canadian goose is the most common goose found in North America. The annual migration cycle of a Canadian goose has many variables. In the spring, adult pairs of geese leave southern non-breeding sites to fly to breeding sites in the north. Typically from March to April, geese breed and then lay eggs. In late April to early May, the eggs hatch. After hatching, a common brood rearing habitat for geese families is a pond near a lawn. Unlike birds such as robins, which can't feed themselves at birth without parental support, geese are precocial, I think is how you say that. The molt occurs in mid-June through late July. During this time period, geese lose their flight feathers, which allows them to grow a new set for fall migration. Geese cannot fly during the molt. By August, geese start to fly again. In September and October, geese fly south for the winter. The word precocial most likely means which of the following? A, unable to feed without parental support at birth. B, able to feed without parental support at birth. C, the yearly migration cycle geese undergo. Or D, the process of geese shedding old, worn feathers to regain a new pair in mid-June through late July. So now's your chance to pause the video, try to figure this out, take all the time you need, reread if you need to, and whenever you're ready, we'll go over the answer. Okay, so thank you for sticking with me here. Let's talk about the answer to this. So first, it would probably help us to find the word in the passage here. So right here, it's precocial, I think is how you pronounce that. That's how I've been saying it so far, at least. But anyway, the sentence here says, unlike birds such as robins, which can't feed themselves at birth without parental support, geese are precocial. So basically, if robins can't feed without parental support at birth, all right, but geese are different from the robins in that sense, we would assume that the geese are able to feed without parental support at birth. So we would conclude that B is the correct answer here. Okay, so this time we have the same passage, but a little different question down here. The question says, Sharon takes a walk on a trail beside her local pond. She notices many feathers scattered on the ground. Based on the information in the passage, what is the most likely time of year? Is it A, late April to early May, B, March to April, C, August, or D, mid-June through late July? So now's your chance to pause the video, try to figure this out, take all the time you need, and if you get stuck, don't worry because we're just going to go over the answer. Okay, so in this question here, basically what you need to see here is that the molt occurs in mid-June through late July, and molting is when the geese lose their flight feathers, basically. And so if they're going to lose their feathers, there's going to be more feathers on the ground, most likely. So the best guess that we could make here is that if Sharon goes for a walk around the pond and she's seeing lots of feathers all over the place, okay, it's probably going to be mid-June through late July because that's when they're losing their feathers. So D is the correct answer here. So this first champion shoutout goes to a test taker who's going through a bit of a challenging time right now, and I'm not going to read every word of this comment here for the sake of time, but the test taker says, I have to get my GED so I can go to the Army. Too much depends on me passing this. I have people doubting me and people cheering me on. I put this pressure on, so I'll go through with it. Nervous, anxious, just overall losing it, but I'm excited at the opportunity. If I do it, I'd be passing 2 big milestones under a month and just completely setting my life to an ocean of opportunities to study and get a job. I feel it. Making a story I myself would be happy to read. So I just want to say that we're all in this together, and, to the test taker who wrote this comment, I just want to say that, I'm cheering for you. Everyone watching this video, I'm sure, is cheering for you too. We all want to see you succeed. My main mission here with Test Prep Champions is to help people who are going through hard times and challenges move ahead by using the GED as a stepping stone to get access to better opportunities like college or a better job or join the military. And I just want you to know that I am cheering for you here, and I'm wishing you the best of luck with everything. So the second champion shoutout goes to a GED test taker who just passed science with a very high score and says, I am 45 from South Africa, passed my GED science with 172 today. I'm not a book guy, so I watched all of your science videos. And so I just want to give a shout out to this successful test taker. A Punnett square can show all of the possible combinations of alleles for color in offspring pea plants when 2 colored hybrid pea plants are crossed. A capital P represents the dominant color, purple allele, while a lowercase p represents the recessive color, white allele. A combination of 2 dominant alleles results in purple offspring. A combination of 1 dominant and 1 recessive allele results in purple offspring. A combination of 2 recessive alleles results in white offspring. One parent's alleles are seen on the left-hand side of the square, and the other parent's alleles are seen on the top of the square. The genotypes of the offspring are missing from the boxes below. So the question is to fill in the missing allele combinations. Now, you obviously won't be able to write on the screen, but maybe draw out this square for yourself, or however you want to do it. You can also just kind of picture how the combinations would go. Whatever works for you, but now's your chance to pause the video, try to figure this out. And if you get stuck, don't worry. Okay, I'm just going to show you how to do it. Okay, so basically all I'm going to do is I'm going to take this big P from the left, put it right here, and then I'm going to take this big P from up top here and just drop it right down here. So I'm going to take the big P from over here and put it right here. Then I'm going to take my little p and drop it down right here. Now this box right here, I take my big P from the left. I'm going to take a big P from up top, so I've got big P, big P. Now this box right here, I take my big P from the left, and I'm going to take my little p from the top and put it right here. Okay, so this is how the box here should be filled in. Okay, so the next question is using the same information, and now the question says, what percent of the offspring will be purple? A, 0%, B, 25%, C, 50%, D, 100%, or E, none of the above. So now's your chance to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So a combination of 2 dominant alleles is going to result in purple offspring. So 2 dominant alleles would be a big P and another big P. Okay, so that's going to give us purple. Now it says a combination of 1 dominant and 1 recessive allele results in purple offspring. So if we've got 1 dominant, 1 big P, 1 recessive, 1 little p, okay, that's also going to give us purple. It also tells us that a combination of 2 recessive alleles is going to give us white offspring. So to get the 2 recessive alleles, we'd have to have 2 lowercase p's. When we look down here at our Punnett square that we filled out, I see big P, big P, big P, big P, big P, little p, and big P, little p. So I don't see any combinations of 2 little p alleles. So in other words, every single combination here is going to give us purple offspring. So D is the correct answer here. Michael wants to make scrambled eggs on his friend Tammy's gas stove. The first thing he does is set the frying pan on the burner. Next he turns on the burner. The gas burns. As a result, the frying pan heats up. Michael cracks the eggs, stirs them, then adds them to the pan. The eggs absorb the heat from the pan and eventually harden into scrambled eggs. Please match each term on the left in blue with the proper steps on the right, yellow. Alright, so now's your chance to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So let's think about when the gas burns, right? So the gas burns, the temperature goes up, and energy is given off. So this step is exothermic. And for endothermic here, right, the eggs harden because they absorb energy from the surroundings. Okay, so this is endothermic. So this is how they should be correctly matched up. So again, like I mentioned earlier, the most important things to know for exothermic and endothermic questions. For an exothermic reaction, energy is given off and temperature increases. And for an endothermic reaction, energy is absorbed and temperature decreases. So right now, you're probably not too happy if you're having trouble seeing this text, especially if you're on a phone. But unfortunately, this is the only way I could fit it on the screen. So let me read this. It says, areas and bodies of water associated with vegetation offer habitat to members of the sunfish family, in particular the bluegill. Researchers wanted to try to better understand why the bluegill commonly uses these habitats, suspecting that areas with vegetation play a role in sheltering bluegill from predators, particularly the largemouth bass. The researchers wanted to test the assumption that higher density of vegetation results in fewer bluegills captured by largemouth bass. The experimenters prepared 4 steel circular pools. Each pool had white walls to permit viewing of the fish. Water temperatures range from 15 to 23 degrees Celsius, with no more than a 2 degrees Celsius change during any day. Rope strands were developed to simulate plant stems. Each pool was prepared with a different density of rope strands. Pool 1 contained 0 stems per square meter. Pool 2 contained 100 stems per square meter. Pool 3 contained 300 stems per square meter, and Pool 4 contained 1,200 stems per square meter. Each pool contained 1 largemouth bass and 38 bluegills. Each bass was starved for 24 hours before the experiment. Before testing, the bluegills were held in a wire cage underwater to prevent the bass from accessing them in each pool. The researchers started a 60-minute timer and then let the bluegill out of the cage in each pool. The researchers stood on 4-meter-high ladders above each pool and observed the behavior for 60 minutes. The researchers observed the following results for the number of bluegills captured per pool, which is listed in this table here. So the question says, which statement below is best supported by the results of the experiment? In the pools with the highest stem densities, the lowest number of bluegills were captured. B. In the pools with the highest stem densities, the highest number of bluegills were captured. C. In the pools with the lowest stem densities, the lowest number of bluegills was captured. D. In the pools with the highest stem densities, the researchers observed the most predatory behavior by the largemouth bass. So now's your chance to pause the video, take all the time you need, and whenever you're ready, we'll go over the answer. So what you need to see here is that the stem density goes up with each pool, right? So pool 1 has 0, then pool 2 has 100, pool 3 has 300, pool 4 is up to 1200. Okay, so basically, Pool 4 had the highest stem density but the lowest number of bluegills captured. Pool 3 had the second highest stem density but the second lowest number of bluegills captured. Okay, so the pool that had the most bluegills captured was Pool 1, and Pool 1 had 0 stem density. Okay, so basically what we're seeing here is that the pools with the highest stem density also had the lowest number of bluegills captured. So A is the correct answer here. So hopefully that makes sense. A small pond ecosystem contains Daphnia bluegills and largemouth bass. Based on this oversimplified food web, what would most likely happen if Daphnia were removed from the pond? A. The bluegill population would increase. B. The largemouth bass population would increase. C. The bluegill population would decrease. Or D. None of the above. And so right here we see a Daphnia, a bluegill, and a largemouth bass. And down here, this has nothing to do with the question. This is just the image credit for this Daphnia here. I just removed the background. And I don't have to give credit for the bluegill or the bass picture because these are both fish that I caught and took the pictures myself, as you can see here. And so, for example, all I did was I just removed the background, so I got the picture of the bass and turned it on its side, and I did the same thing with the bluegill. But anyway, here is your question, and I'll give you a chance to pause the video, take all the time you need with this, and whenever you're ready, we'll go over the right answer. So in a question like this, what you need to know is that the arrows are showing energy transfer. All right, so if the bluegill eats the Daphnia, that energy is going to transfer from the Daphnia to the bluegill, and the same with the bass. All right, so the bass eat the bluegill eat the Daphnia. I've had some test takers comment before and say that the way the arrows point, it almost makes it look like the Daphnia eat the bluegill and the bluegill eat the bass. So just keep in mind the arrows are not showing which species eats which species. The arrows are actually showing energy transfer, okay? So with this in mind, if we take out the Daphnia, and this is oversimplified, right? So if we assume, though, that for the purpose of the example that the bluegill's only food source in the pond is Daphnia, what's going to happen if we eliminate that food source? Well, the bluegill aren't going to have that food source anymore, and eventually they're going to starve, and eventually the population of bluegill is going to decrease because they're going to starve. So C is the correct answer here. Poor bluegills. So in the champion facts segments of my videos, I like to pop out from behind the screen and answer a few random questions from a generator, and I do this just to give you a break from thinking so hard and make the video more fun and entertaining. And if you think I'm just wasting your time by doing this, let me know down below in the comments. I do want to hear your opinion. So my first question today is, what's one thing that you constantly lose? Well, for me, I constantly lose my TV remote. What recent experience made you feel old? Well, pretty much being a parent myself now makes me feel older, I would say. What's an interesting fact that you learned recently? I learned that geese can't fly during the summer. What thing from your childhood do you still enjoy to this day? I would say video games, although I don't have time to play very often, but I still like N64, PS1, PS2 games, pretty much the same types of games I liked when I was a child. So the most famous person that I remember meeting was Bam Margera, the skateboarder who used to have that show Viva La Bam. A researcher wants to test if a new prescription drug will help people experiencing chronic insomnia sleep better. Defined as those who have had difficulty sleeping for 3 or more nights per week for more than 3 months. The researcher guesses that those who take the drug will get more hours of sleep per night on average than those who do not. The sample size is 200 individuals who have been diagnosed with chronic insomnia by a doctor. The researcher divides the sample subjects into 2 groups. One group is given the prescription drug, while the other group is given a placebo. This is a double-blind study, which means that neither the subjects nor the researcher knows which group is receiving the drug and which is receiving the placebo. Over a 3-month period, the subjects are asked to self-report how many hours of sleep they got the night before in a smartphone app each morning. After 3 hours, the individuals in the group receiving the drug averaged 7.5 hours of sleep per night, while those in the group receiving the placebo averaged 5 hours of sleep per night. So your question here is, what is the hypothesis? And we don't have multiple choice answers for this. This is just for you to come up with the answer. And whenever you're ready, or I should say you should pause the video if you'd like to, and whenever you're ready, we'll go over the answer. So a hypothesis is basically a fancy word in science that means an educated guess. And so really this word guesses right here is kind of your clue to where you can find the hypothesis. But basically the hypothesis here is that those who take the drug will get more hours of sleep per night on average than those who do not. So the next question says, it's dealing with the same passage. It says true or false. The result of the experiment supports the hypothesis. Is this true or false? So now is your chance to pause the video, take all the time you need to figure this out, and whenever you're ready, we'll go over the answer. Okay, so let's look here at the result, and basically there was one group. The group that took the drug got 7.5 hours per night, which is more than the group that got the placebo. And the placebo, that's just like a fake pill, basically, that doesn't do anything. And the placebo group got 5 hours of sleep, which is less. So the researcher initially hypothesized that those who took the drug would get more hours of sleep per night, and that is exactly what the result shows here. And so the hypothesis here, the result of the experiment does support the hypothesis, so the correct answer here is A, true. Tommy, do you have any tips for GED science you'd like to share? The melting point of a substance is the temperature at which it changes from a solid to a liquid. The boiling point of a substance is the temperature at which it changes from a liquid to a gas. Based on the information provided above, which element shown in the chart above is a liquid at 100 degrees Fahrenheit? Is it A, phosphorus? Is it B, gallium? Is it C, rubidium? Or D, strontium? So it's up to you to try to figure this out. So I'd like you to pause the video now if you want to. Take all the time you need. As always, if you get stuck, don't worry, because we're just going to go over the answer. So I'll let you try this right now. So the process of going from a solid to a liquid is called melting. And then going from a liquid to a gas is what we call boiling. To figure out which one is going to be a liquid at 100 degrees, we should first check the melting point. So At 100 degrees, will phosphorus have melted? Nope. Phosphorus is not going to melt to 111.4 degrees. So phosphorus is going to be a solid at room temperature. Now, what about rubidium? So rubidium is going to melt at 103.1 degrees. And so at 100 degrees, rubidium is not hot enough to melt yet, so rubidium is going to be a solid. Same with strontium. Well, strontium is a really high melting point, so at 100 degrees, strontium is not even going to be close to melting yet. So now we look at gallium right here, and so at 85.58 degrees, gallium will transition from a solid to a liquid, so therefore at 100 degrees, gallium is going to be our liquid. So B is the correct answer here. Tommy, I was going to let you teach the next question, but it looks like you just want to play video games, so maybe we'll try in another video. What is the mean melting point in degrees Fahrenheit for the elements in the chart above? Is it A, B, C, or D? Now's your chance to pause the video and try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so to calculate the mean, I'm going to take 111.4, and I'm going to add 85.58. Then I'm going to add 103.1. Then I'm going to add 1,431. So as you can see, all I did was I'm going to take my first step, take all the melting point values here, I'm going to add them up, and I'm going to divide by 4. Now, the reason that I divide by 4 is because we have 4 different values here in our data set. So that's why I divide by 4. All right, so if you do this in your calculator, you will see that B is the correct answer. If you got answer choice C, you did a really good job of calculating the mean for the boiling points, but the question was asking us to calculate the mean for the melting points. So the next question says, what is the median boiling point in degrees Fahrenheit for the elements in the chart above? So now's your chance to pause the video, take all the time you need to figure this out, and whenever you're ready, we'll go over the answer. Okay, so in this case, we want to find the median for the boiling points. So the first step is to put the numbers in order from smallest to largest. And for median questions, a lot of times students remember that median has something to do with the middle number. And so they'll go right after trying to find the middle number, but sometimes they forget to put the numbers in order from smallest to largest. And that's a really common, really easy mistake to make. Okay, so don't feel bad if you did that, because that is, like I said, that's one of the most common mistakes that I've seen. All right, but remember that on your test, if you get a median question, you want to look at the numbers and put them in order from smallest to largest before we do anything else. So with the numbers written in order from smallest to largest, since we have an even number of numbers in our data set, I'm going to have to take the 2 numbers in the middle and I'm going to have to add them up and divide by 2. So I'm going to do 1,270 plus 2,519. And I'm going to divide this by 2. So the answer I get is B. Okay, so the next question says, what is the range melting point in degrees Fahrenheit for the elements in the chart above? So I'll let you pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so now we have to look at the melting point values again, and we have to calculate the range. So to find the range here, what we're going to do is we're going to take the biggest number and we're just going to subtract the smallest number. So I just did this in my calculator off the screen here and I got B is the correct answer and B is the correct answer. So hopefully this makes sense as far as how to calculate the range. Please balance the following chemical equation. Fe2SO4 plus KOH yields K2SO4 plus FeOH3. Now in this case, we don't have multiple choice answers. This is just for you to come up with your own answer. So now's your chance to pause the video. And if you get stuck, don't worry about it because we're just going to go over this. We only care about the learning right now. We don't care if you get it right or wrong. So to help guide us through this question here, I like to write everything out here on both sides, and you can definitely do it this way on your test. Eventually, you might get to the point where you get so good at these that you don't have to write all the steps out, but for teaching purposes, I think this is the best way to do it. So let's just take stock of everything that we have. So for Fe, I've got 2. So I'm just going to put Fe2 right here. Now, how many S's do I have? Well, I have to take this little 3 that's outside of the parentheses, and I'm going to have to apply this 3 to both the S and also to the O. So I've got one S inside the parentheses, but I've got to multiply it by 3. So it looks like I've got 3 S's so far. Now, what about my oxygens? Well, I've got 4 oxygens in the parentheses, but I also have to apply this 3. So I do 4 times 3, so I'm starting with 12 oxygens here. So let's keep going. I've got my KOH. So K is easy enough. I've got 1 K. Now, I've got another O here, so I'm going to have to add 1 O. So instead of having 12 O's, I really have 13 O's on the left-hand side. And I've got this 1 H right here. Okay, so I've taken stock of everything I have on the left-hand side of the equation. And when I say left-hand side, I just mean everything to the left of my arrow. Now let's do the same for the right-hand side. So everything on the right, I'm going to take stock of it right down here. K2SO4. So how many K's do I have? Well, I've got 2 K's on my right-hand side. So I'm going to start off by putting a 2 right here. Now I've got 1 S over here, and I've got 4 oxygens to start off with, so I'll put a 4 right here. Now I come over here to my FeOH3. So for Fe, I've got 1. For my oxygen here, I've got 1 inside the parentheses, but I have to take this 3 and multiply that by 3. So I really would have 3 oxygens. Okay, so let me add that. So I had 4 oxygens, 4 oxygens from my K2SO4, plus another 3 oxygens from my FeOH3. So that gives me 7 oxygens. Now for this hydrogen, I've got 1 inside the parenthesis. I also have to multiply by 3, so I have 3 hydrogens on the right-hand side. So to balance this, I've got to get all these numbers to match. So this is kind of a choose-your-own-adventure at this point, but I'm going to start off with this FeOH3 right here. So I've got 2 Fe's on the left-hand side, so I'm going to just stick a 2 out front of here. And now I'm going to recount everything. Okay, so for my Fe's now, I'm going to have 2. Now, my oxygen is going to double. All right, so my oxygen here, instead of being 3, okay, this 3 here is going to become a 6. Now I'm going to have to re-add up my oxygen. So 4 plus 6 gives me 10. So the same with the H's here, right? So I originally had those 3 H's, but I put a 2 out in front, so everything here is going to be multiplied by 2 now, all right? So this H is going to become 6, because 2 times 3 is 6. Now my Fe's are balanced, but I still have some work to do, right? So now what I'm going to do is, let's see if I can balance the H's. I'm going to take this H right here. I've got 6 on my right-hand side, so let me stick a 6 out here. All right, so now on my left-hand side, I've got to change some things here. So 6K. So instead of having just 1K on the left-hand side, now I have 6. Right here, this 1 is now going to become a 6 because 6, I've got to multiply that by that 1 oxygen there. All right, so that becomes 6. Okay, so my 12 oxygens that I got from my Fe2SO43, that's going to be the same. So now this 6 also is going to, I'm going to take this 1 hydrogen and multiply that by 6. All right, so now I've got 6 hydrogens. So now what we can see here is that I've got my hydrogens balanced up. I've got my Fe's balanced up here. I still have some work to do, though. I see that I've got 6 K's on the left-hand side and 2 on the right-hand side. So let me stick a 3 right here and see what this does. So 3K2, that is going to be 3 times 2, so I can make this 6. My K's are looking good. Now for my S's, I've got 3 out here, so I've got to do 3 times this 1 S. So now on the right-hand side, I'm going to turn this into a 3. So what about my oxygens? Well, I've got 4 oxygens here, but I have to multiply that by 3. So 3 times 4 is 12. So I've got to go back to this 4 right here, and I'm going to turn this into a 12. Now 12 plus 16 is what? 12 plus 16 is 18. Okay, so now everything's balanced up, so this is the correct answer right here on the screen. So for balancing questions, the 2 most important tips I have are never change those little numbers that are after the chemical symbols. Those are called subscripts. You don't want to change those. Only change the numbers out front, which are called coefficients. Also, never leave a question blank, and if you're spending too much time on any one question, I recommend guessing, marking that question, then coming back to it